Dear students, welcome to PMDC online lecture room. Today I will talk about access reagent and limiting reactant. This topic is present in chapter number 1 named Stoichiometry of grade 11 chemistry book. Our today's lecture consists of two parts. Number 1, access reagent. Number 2, limiting reactant. So first we are going to discuss access reagent. The access reagent is defined as those reactants which are present in a large quantities in a reaction. They are called access reagent. The second part of today's lecture is limiting reactant. This topic includes definition of limiting reactant, explanation, examples, identification of a limiting reactant, problems, and assignment. Now first we are going to define limiting reactant. A limiting reactant is defined as a reactant which is used up first in a reaction, or a reactant which produces least amount of product in a chemical reaction. Now we are going to explain the limiting reactant. When reactants are not present in stoichiometric amount, then at the completion of a reaction, some reactants left behind, while others may be consumed completely. Those reactants which consume earlier are called limiting reactant. Some of the examples of limiting reactant are: look at this slide on which we are going to explain a journal example of a limiting reactant. In this example, we are considering 3 cars without tires as a one reactant for a reaction, and 15 tires as a second reactant for a reaction. Now these cars need 12 tires, while the rest of the 3 tires are extra. Is these cars are less in number while the tires are large in number, therefore in this example the cars acts as a limiting reactant while the tires acts as access reagent. Now dear students, we are discussing the exact example regarding limiting reactant. Number 1, in combustion reactions, one of the reactant is oxygen, which is present in a large quantity, while other reactant may be wood, coal, or gasoline, which will act as limiting reactant. Second example, during lightning in the sky, oxygen gas and nitrogen gas react to form oxides of nitrogen. As in the air, the percentage of oxygen is 21 and The percentage of nitrogen is 78. Since oxygen quantity is less, therefore oxygen in this reaction acts as a limiting reactant, while nitrogen, due to large amount, acts as an excess reagent. Now, the steps which are used to identify limiting reactants are: number 1, write down the chemical balanced equation. Number 2, convert the amount of all reactants into moles. Number 3, the molar amount of the required product is calculated from the molar amount of all reactants. The last step for solving the numerical is the reactant which produces least amount of product is the limiting reactant. Dear students, let's start to apply these steps on the following problems. Number 1, look at this problem. In this problem, two reactants, manganese dioxide and hydrochloric acid, react to form manganese chloride, chlorine gas and water. The data shows that in the problem manganese dioxide is given in moles while hydrochloric acid is given in grams. Now we are going to apply the various steps. Step number 1, write down the balanced chemical equation. The balanced chemical equation shows that 1 mole of MnO2 reacts with 4 moles of HCl to form 1 mole of manganese chloride, 1 mole of chlorine and 2 moles of water. Now according to the second step, in this step the amount of reactants in grams are converted into products. In this problem, the mass of HCl is 48.2, which is divided by 36.5. This 36.5 is the molar mass of HCl. As a result, we will get 1.32 moles of HCl. Now we are applying the third step. It is clear from the equation that 1 mole of manganese dioxide produces 1 mole of chlorine, while 0.86 mole of manganese dioxide will produce 0.8 mole of chlorine. Similarly, the 4 moles of HCl produces 1 mole of chlorine in the balanced chemical equation, while 1.32 mole of HCl will produce 0.33 moles of chlorine. If you look at this equation, it is clear that manganese dioxide produces 0.86 mole of chlorine during the reaction, which is large quantity, while HCl produces 0.33 moles of chlorine, which is less quantity. Now we are applying the last step, and that is the reactant which produces least amount of product is the limiting reactant. As we have noted that HCl produces least amount of product in this problem, that is 0.33 mole of chlorine. Therefore, it is a limiting reactant. While MnO2 produces large amount of product, therefore it is an excess reagent. Now consider another example. In this example, the data shows that mass of chlorine is 20 gram, mass of aluminium is 20 gram, mass of chlorine is 30 gram, and we are going to calculate limiting reactant. According to the first step, this is the balanced form of a reaction. Now the second step, in this step we will convert the masses into grams. After converting the mass of aluminium, we will get 0.74 moles of aluminium and 0.422 moles of chlorine. Now according to the third step, two moles of aluminium produces 2 moles of aluminium chloride. 0.74 moles of aluminium will produce 0.074 mole of aluminium chloride. Similarly, 3 moles of chlorine produces 2 moles of aluminium chloride. 0.422 moles of chlorine will produce 0.28 moles of aluminium chloride. This shows that aluminium during the reaction produces 0.74 mole of aluminium chloride product, while chlorine produces 0.28 moles of aluminium chloride. Now applying the last step. As in previous slide, we noted that chlorine produces least amount of product, 0.28 mole of aluminium chloride. Therefore, it is a limiting reactant, while aluminium is an excess reagent. Dear students, if you have carefully watched and listened the lecture, then you can solve this assignment very easily. Thank you very much and take care.